The term base graphics refers to the graphics system originally built into R language. This is default graphics system and easiest to learn. So we will use this system to demonstrate some of the graphics capabilities in R. All the plots in the base graphics are built on one single generic plot function. It generates the output based on nature of object to which it is applied. Plot function generates scatter plot if two numeric variables are supplied as an input. Plot function generates bar plot if one factor object is supplied as an input. Plot function generates the box plot if one factor and one numeric variable is supplied as an input. And also the plot function generates matrix scatter plot if the data frame is supplied as an input. So with the single plot function, we can generate so many different visualizations. Here are 6 basic plots you will end up using most of the times during exploratory data analysis. So we will limit our discussion to these 6 charts. In this video, we will discuss the scatter plot. Scatter plot plots numeric value of one variable against the other. It also graphically shows how each variable relates to others. Here is a function to produce a scatter plot. A is a x-axis value, a numeric variable mapped to x-axis. B is numeric variable mapped to y-axis. Main is the title of the graph. And x label and y label are the x-axis and y-axis labels. So let's open the RStudio and use the plot function to generate the scatter plot. We will work with empty cars dataset. This dataset is about various automobile parameters for 32 different car models. We are interested in looking at the relationship between the MPG variable and HP variable. So how average fuel consumption in miles per gallon MPG is changing related to engine size in horsepower. So we will use the plot function. On x-axis we will use MPG variable and on y-axis we will use HP variable. We will name our chart as miles per gallon versus engine horsepower. The x-axis label is miles per gallon and the y-axis label is engine horsepower. So let's execute this command now, and we got the scatter plot. You can observe how we have a negative relationship between engine size in horsepower and fuel efficiency in miles per gallon. So as engine size of the vehicle increases, the fuel efficiency is reduced. We can bring in third variable on a scatter plot. We will generate the same scatter plot, MPG versus HP, but we will differentiate each point now by a number of engine cylinders. So we'll use a color aesthetic and assign it to variable cylinder. Let's see what we get. We could now differentiate the points based on the number of engine cylinders. So looking at the dataset, and after we arrange the data in ascending order as per the cylinder variable, you can notice that the 8-cylinder engine is having less mile per gallon compared to 6-cylinder and 4-cylinder engine. By looking at the scatter plot, we can only differentiate the points based on the different colors. But which color indicates which cylinder engine is not clear to us. So let's put the legend on the scatter plot. We can use legend function, mention the position of the legend, create a character vector for the colors being used in the chart, and legend used for each color. And after we execute, you can see the legend being displayed on the scatter plot. The green color dots are the vehicles with 4-cylinder engine. The red color dots are the vehicles with the 6-cylinder engine, and the black dots represent the vehicles with 8-cylinder engine. We can generate a scatter plot matrix for multivariate data. So if you want to generate a pairwise scatter plot, say for 5 variables, it means 20 pairs put together. We can do it with pairs function. The pairs function produces a scatter plot between all possible pairs of variables in dataset and these pairs are arranged in a matrix with a plot scales constant over rows and columns of a matrix. So in this video we looked at scatter plot. In the next video we will generate a bar charts. So stay tuned on this channel. I will see you in the next video.